Okay, we're back, and now we want to do part 3 of the lab, which is on separation of electrical charges. So matter is composed of atoms, and atoms are composed of a nucleus, which is positive because it has protons in it, and then it has negative electrons in orbit around it. And the the reason why the atom stays together is because the positive nucleus and the negative electrons are opposite charges, and opposites attract. And so that's what keeps the atom together. So if you take two substances and you rub them together, then what can happen is that the negative electrons can be rubbed off the atoms, and then we separate the electrical charges. So one substance has a net charge of positive, and then the other substance has a net charge of negative. And we're going to kind of explore this idea. Now, one thing that's critical to this is conservation of electrical charges. So that means that if you have a substance that is electrically neutral, equal numbers of positive and negative charges, and then you separate it, okay, you can't create electrical charges. You can separate them. So if this thing here is electrically neutral, okay, and then I pull the top off of it, and now for some reason this has a net charge of +6, then this thing has to have a net charge of -6, so that when you add them back together again, +6 and -6 is going to be 0 again. So this thing was originally 0, and then afterwards it's still 0. So I didn't create any electrical charges. So this is what we're going to mean by conservation of electrical charges. Okay, so let's go on down a little bit further here. And so I've got this chart here that shows all different kinds of electrical surfaces. So you've got paper and aluminum and iron, and it shows what would happen when you rub that substance on something else. So the ones up there at the top tend to lose electrons very easily, because if the electrons are negative and a substance loses those negative electrons, it becomes positively charged. So the ones up at the top tend to lose electrons very easily. So you see it's positive, positive, positive. Now the closer that you get to that pink line there, cotton, what happens is that they don't want to lose the electrons as easily. So that by the time that you're down to paper, doesn't really like to lose electrons, but it will lose electrons, just not as many. So you see that the ones down at the bottom are more of a positive, and the ones up at the top are a positive, positive, positive. And then cotton is, you see that cotton is right there in the middle. So it normally doesn't like to give electrons, and it doesn't like to take electrons. Now the ones underneath it though, okay, those are the ones that like to take electrons. And so if they're taking negative electrons, they become negative. And so the ones down here, they don't really like to take electrons that much, but they will. And so you see that they're given a negative, and then the ones down here at the very bottom, they really like to take electrons. So they're negative, negative, negative. Okay, now one of the questions that I'm going to ask you is, what would happen if you take one of these and you rub it with one of these? Which one's going to be the positive one, and which one's going to be the negative one? Now you're saying, well, they're both going to be negative. okay, because it's negative up here and it's negative down here. But what's going to happen is one of them is going to want to take the electrons more than the other one. So the one that's going to want to take the electrons more is going to be the negative one, and then the one that wants to take the electrons less is going to end up being the positive one. Now, what we're going to be doing is, in the simulation, we're going to be rubbing. So let's now go to the simulation. So you're going to go to PhET and type in PhET, balloons, and static electricity. Okay, now this is what you're going to come to. So there's the simulation. Now you got a jacket here, and then you got a balloon. What do you think the balloon is made of? Okay, so write that in the lab. You should know what most balloons are composed of. Okay, then this thing over here, we're going to pretend is wool. So this is going to be a wool sweater, and then we're going to rub a rubber balloon on it. And then first note, and then this over here, this is a wall. And look at the red ones, which are the positive charges. So this would be the nucleuses of the atoms that comprise the wool sweater. And then the blue ones are the negatives. So those represent the electrons that are in orbit around those nucleuses. So do you notice that for every positive there is a negative? So that means that originally this sweater was electrically neutral. And then look at the rubber balloon. So it's also electrically neutral. So what you're going to do is grab the balloon. So if you click on the balloon, you can move it around. Okay, and now notice nothing's happening as I move it around until I rub it. Okay, so now I can rub it on there, and you should notice that a particular kind of electrical charge goes to the rubber, and a particular kind of electrical charge stays on the wool. Now I want you to verify this using that chart. So find wool and find rubber on the chart, and then find out which one tends to become negative and then which one tends to become positive. Okay, now that's not the entire experiment. So the next thing that the lab calls for is to let the balloon go, and I'm not going to do it. So well, how can I do this? I reset the balloon. Oh, I think you know what was going to happen there. So I don't want to spoil the fun of using the simulation for you. But you're going to let the balloon go, see what happens. Can you explain what force caused that to happen? Okay. And then another thing that you're going to do is, once you got your balloon charged up, you're going to bring it over to the wall, and you're going to see what happens, and see if you can explain that as well. Now, one thing that's going to be about this is that these are non-conductors. So a conductor is a metal. It allows electricity to flow through it. But these are non-conductors. So this means that the electrical charges, they can be separated, but they don't flow through the material. And you'll notice that the electrons, they don't flow into this thing over here, but what they can do is they can congregate on the surface of it. And then what that's going to do is it's going to change what we call the polarity of the atoms that are in the wall. So it can cause them to be separated. All right, so that is that simulation. So now you've got some stuff where you're going to be filling in the blanks. And remember, anything that you do, make sure and do it in red so that I can see what you did. And you're going to be answering all of these questions here. So now we're going to take another break, and when we come back, we are going to do the PhET simulation, John Travolta.